to Lesson 2-2, Solving Systems of Inequalities. The Great Math Adventure today takes us to Lakewood Amphitheater. You guys go ahead and have your packets out ready to look at the notes. I'm going to wait for Matchbox 20 and Counting Crows to come on. Alright, so with System of Inequalities, basically all we are going to be doing is we are going to be taking the basic skills that we learned in 1-8 on graphing System of Inequalities on the coordinate plane, and instead of just graphing one of them at a time, we're going to be graphing two of them on the same plane and looking at where they're going to cross and intersect. So before we jump in too much further into this video, if you do need to review some of the basics on how to graph an inequality, feel free to check out 1-8's notes and videos to help give yourself a little bit of a refresher on that. So as we said, when we graph an inequality, instead of just graphing a straight line like we do when we're graphing an equation, we have to shade a region, and we're going to look at several possible solutions instead of just the solutions on the line. Now, the solution set to a system of inequalities, you're going to have to graph both of the inequalities and then look for where their shaded regions overlap or intersect. So we're going to just be doing the same basic skills we did in 1-8. You will need to be graphing both of them, however, on the same graph. Now, in this little example, we just have it broken down so you can kind of see how all you're doing is graphing one inequality and then graphing a second. The last example is going to show what it's really going to look like on your paper, where they're both graphed on the same part. We just wanted to pull it apart so you can see how all it is these two overlapping each other. So when you are doing a system of inequalities, you will just want to start out by graphing your two inequalities. So that's what's being done in this first problem. We have y is less than or equal to 2x plus 3. We have a y-intercept of 3 and the slope of 2 over 1. So we would go up 2 and over 1, up 2 and over 1. We look at our sign, remember, to tell what we're going to need to do with the line and our shading. Remember, if it has that line underneath it, it means it's equal to. So we're going to draw a solid line. And then anytime we see a less than or equal to sign, that means we're going to shade below the hill like we have here. In our second inequality, we have y is greater than negative x minus 6. Our y-intercept is negative 6, and our slope would be negative 1, so down 1 over 1. Now you notice this one does not have the line underneath the inequality, so we had to draw a dashed line instead of a solid line. And we have a greater than symbol, which means we're going to shade above. Now this last image on this graphic here shows the two put together. All this is done is taken the first graph and the second graph and put them on the same place. Now you'll notice this dark region is where both of them are shaded. That is going to be where we find our solutions, where our shading is going to overlap. What I would highly recommend for you guys is to use some colored pencils on this lesson. It's a lot easier to see where they're going to overlap. So for example, if I was shading this region, I might shade it in purple. And then if I was shading the other ones, I might shade it in green. And it makes it a lot easier to see where these are overlapping than when you just use the gray of a regular pencil. So what we find in this is that our solutions to this particular system of inequalities is going to be where that green and the purple overlap. Any ordered pair within that area that's shaded in both colors is going to be a solution. So when we're asked to identify two ordered pairs as our part of the solution set, we can pick any two ordered pairs that are within that shaded region, and they will work as solutions for us. Alright. Also, one other thing to note, if it's on the solid line, it will be a possible solution. If it's on a dashed line, remember that does not mean it's equal to, so something on the dashed line would not work. But if we were to ask to give two ordered pairs that are in the solution set, we can pick any two ordered pairs within this region. There's an infinite number of possibilities. I'm just going to pick two of them. So for example, we have the origin, 0, 0. That is in both the purple and the green. So I'm going to write that as one possible solution. And then let's just say something over here, 10, 0. And you could list a dozen other situations. The important thing is that it falls within both of those shaded regions. Now sometimes you might also be asked to give ordered pairs that are not in the solution set. This is going to be found anywhere outside of the purple and green here. It could be where we just have green, it could be where we just have purple, or it could be where it's not shaded at all. So I'm just going to pick 2 points out of here. Again, there's a whole bunch of different situations you could pick. And let's say negative 10 and 0, that's in a region that's not shaded at all. But we also can pick something that's in the region that's shaded in just one color. So for example, -4 and +4 would work because that's in the green, but it's not in the green and the purple. So one thing that we do have to be careful with is that when we have system of equations, anytime that we had parallel lines and we graphed them, we said there was no solution because those lines were never going to cross. However, when we are going to be graphing systems of inequalities, because we have to take into account the shading, we are going to have possible solutions with some of our parallel lines. Now we might still have the case where we have no solution if we're shading in opposite directions, but we are going to have some possibilities of parallel lines that do actually have solutions. So for example, in the first graphic, we have y is less than x plus 4 and y is greater than x minus 2. These are parallel lines, but as you can see with the y is less than x plus 4, that top line, we had a less than symbol, so we were shading below. With our second one, y is greater than x minus 2, we are shading greater than, so we are shading above. So we're going to see that in this case, in this little middle section here where both the green and the yellow overlapped, that we're actually going to have a set of solutions in that middle section. And that's going to be all our possible solutions. Alright, looking in the second example, this time both of our signs are going the same way. We have a greater than or equal to and a less than symbol, or sorry, a greater than symbol. But when we go ahead and graph and color these in, the 2x plus 4 is going to be the top line. We want greater than, so we are shading above again. And then with our second one, we have greater than 2x minus 1, so we're going to shade above. So in this case, the solutions are going to be in the double shaded area on one side of the line. Instead of being sandwiched in the middle like an Oreo, they're going to be spread out on the left side of the line. And then we are still going to have some situations where we are going to have no solution. For example, in this third example, we have y is greater than negative 3x plus 5. We shade above that line, so we're going to shade over here. And then we're going to shade less than on the y is less than negative 3x minus 3. And we're going to shade over on the left side here. And as you can see, since we're shading on opposite sides in this problem, there are going to be no solutions. So you do just have to pay a little bit more careful attention when you are graphing parallel systems of inequalities. I know we've trained you guys when you're graphing equations and you see parallel lines to say no solution, but on these you're going to have to go ahead and graph them out and shade them and see where your solution set's going to be. Alright, you guys try the You Try problems. Make sure to check your answers on the webpage, and we'll be back in video 2 to wrap things up.